All right, so today we're going to cover exponential and linear models. So let's say that Alphonse and Becca each have 100 followers on social media. Over the next 12 months, Alphonse is going to increase by 10 a month, and Becca is going to increase by 10% each month. So the essential question that we would like to answer by the end of this lesson is, who would have more followers at the end of the 12-month period? Someone who increases by going up by 10, or someone who increases by going up 10%. So that is the difference between a linear function and an exponential function. So in a linear function, it takes on the form y equals mx plus b. An exponential takes on the form y equals a times b to the x. So if you look down here, we've had lots of experience with lines, so this is what a linear function would look like if you graphed it, and this is what an exponential function would look like if you graphed it. So what do these variables represent? So over here in this one, the b is your starting value. It shows up on your y-intercept. On an exponential function, it is the a that is the starting value. On a linear, the m is the slope or the rate of change. On an exponential, it is the b that is the change, and it is the base or the multiplier. So if m is a positive number, that means your slope is going up. And if m is a negative number, that means you have a decreasing function and it is going down. On this one, if b is a number that's greater than 1, you would have a growth function, and it looks something like this. And if b is a number between 0 and 1, then you get a decay function, which looks something like this. All right, so on this, this says y equals 3x plus 2, and this says y equals 2 to the x. So we would like to create a table of values so that we can say a little bit more about it. So I'm just going to make a table of values, and my x's, I'm going to run from -2 to 2, and same thing over here, -2 to 2. So when I plug -2 in right there, I have 3 times -2, which is -6, plus 2 equals -4. Now I'm going to plug -1 in. 3 times -1 is -3, plus 1 is -1. Plug 0 in, you get 0 plus 2, which is 2. Plug 1 in, 3 and 2 is 5. Plug 2 in, that's 6 plus 2, which equals 8. Now I'm going to plug them into the exponential. So if you plug 2 to the -2 into your calculator, you would end up with a fraction. So in your calculator, I'm going to put 2 in for the base. On my calculator, I have an exponent button, and I would go -2 and hit equals, and I get 1/4. If you have this keypad, you could arrow over and back. You'd have to hit the delete key, and you can change that to a -1. And so that is 1/2. Many of you don't have that calculator, and you have this one. I'm going to switch it up real quick. Clear. So if I'm going to enter 2 to the 0, I have 2. And this one, this upside down V is called a caret key. You would enter 2 to the 0, and you get 1. Now, the next ones you probably don't have to do in your calculator. So 2 to the first is 2, and 2 to the second equals 4. So the other thing that I would like to be able to say is, what if you're looking at a table of values? So if I'm going from -4 to 1, -1 to 2, 2 to 5, and 5 to 8, do I see a pattern? How do I consistently get from one number to the next? So to go from -4 to -1, you would have to add 3. Same thing here. To go to 2 to 5, add 3. 5 to 8, add 3. So when it comes to a linear function, I can get from one value to the next by adding, or if it was a negative function, it would probably be subtracting. So here I would say your y values change by addition or subtraction. So the y values are changing by adding or subtracting. Let's look at this one. So how can I consistently get from one number to the next? So sometimes it's a little bit hard to see at the beginning. Sometimes I focus on the end and see if that holds true. So to get from 2 to 4, you can either add 2 or you can multiply by 2. So the pattern is probably multiply by 2. So 1 times 2 is 2, that works. 1/2 times 2 is 1, and 1/4 times 2 is 1/2. So this one, in an exponential function, I get from one number to the next by multiplying. So up here, I would say my y values change by multiplication. Kind of division, but in division, you can always multiply by a fraction as well. So we are definitely going to be multiplying. So let's compare and contrast what would happen. So at Bank A, they'll give you $10 in interest every single year, and I'm starting with $100 in my account. So I will add $10 every year, and the T is how many numbers of year I left it in there, and then that 100, that's my starting amount. Bank B gives me 10% each year. So this 100, that's where it shows up because that's my starting amount, and it is going up by 10% each year, and so you have to use 1.10. So Bank A, your A of T equals 10T plus 100, and over here, B of T equals 100 times 1.1 to the T. All right, so at the end of year 1, how much would I have? So I'm going to plug 1 in for T. So 10 times 1 plus 100 equals $110. At the end of year 2, so this is nothing more than function notation that I'm using here. So I would have 10 times 2 plus 100. That's 20 plus 100 gives me 120. At the end of year 3, so you would have 10 times 3 plus 100, so that would give you 130. So it also told me up here that it's just simply adding $10 each year. So I would say, okay, I could keep plugging it in, but I know that that's going to be 140, 150, and 160. The exponentials I'm not quite as familiar with, so I'm going to substitute them in. So at year 1, I have 100 times 1.1 to the 1. So in my calculator, clear that out. So I'd go 100 parenthesis 1.1 to the exponent of 1. And I have $110. So that part's the same. On my calculator, I'm going to use the arrow keypad, and I'm going to just keep changing my exponent to a 2, 3, 4, etc. So at the end of year 2, you would have 100 times 1.1 to the second. And now you have $121. So not a huge difference, but it is $1 more. At the end of year 3, let's see, I have $133.10. Change it to a 4. 100 times 1.1 to the 4th gives me 146.41. Change your exponent to a 5. 100 times 1.1 to the 5th. Let's see, I get 161.05. And 100 times 1.1, that is 1.1, I promise you. And I get 177. Money is 2 decimal places. That 6 rounds that 5 up to a 6.16. So we only started with $100, but you can see that at the end of year 2, your exponential had already overtaken. So it is better if you can put your money into an account that grows exponentially versus linearly, because it will grow faster. If you were to compare those that growth over time, I already did it, and so this is what it would end up looking like. So your linear graph is going to grow consistently, but your exponential graph is going to grow exponentially, and so this is what you want out of your account, to grow exponentially. All right, so we're going to read some word problems and compare some table of values, and I'm just going to jot down. So linear growth is y equals mx plus b, and it is going to grow by adding, or it's going to go down, decline by subtracting. My b is my starting number, and my m is my rate. For exponential growth, I have y equals a times b to the x. I am going to be multiplying or dividing, but it is really multiplication. A is going to be my starting amount, and B is going to be my rate. All right, so when I look at the y's, I need to go from 5 to 10, 10 to 15, 15 to 20, and so I seem to be going consistently up by adding 5. So I would say that this one is a linear function. Number 3, 7 or 10 down to 7, down to 4, down to 1. So I know that's a minus 3, that's a minus 3, that's a minus 3. If you jump and you compare it at the end, that is also a minus 3. So this would be an example of a linear function. On number 4, so to go from 3 to 6, maybe you start off and you're like, that's plus 3. Oh, but to go from 6 to 12, that's not plus 3. That would be a plus 6. Well, I'm trying to find a pattern, so maybe I can multiply by the same number. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So this one, I am multiplying to get to the next number. That is what makes this one an exponential function. And on the last one, I'm going from 8 to 4, so that's minus 4. 4 to 2, that's minus 2. Oops, okay, so it's not linear. So what else could I do? So I could divide by 2, divide by 2, divide by 2, divide by 2. All right, so we don't want to divide. If we're going to end up writing, but this is an exponential function. Let's start with that. So for an exponential function, when we write a formula, it is always about multiplication. So dividing by 2 is the same thing as multiplying by a half. So if I take 4 times 1/2, I get 2. 2 times 1/2, I get 1. All right, so let's try to write some equations. So what you need to know is that your starting number right there is always your y-intercept. So I know that I could find the y-intercept when x equals 0. So I have a starting point at 0, 5. So that right there I can tell you is my b. It's going up by 5, so that is your m. So I know that this is the equation, y equals 5x plus 5. On the next one, when x is 0, that is your starting amount. That right there is your b. It's your y-intercept. So y equals mx plus b. This number right here, going minus 3, minus 3, minus 3, that is your m. So m is negative 3x. And then b is negative 2. If I want to try to write an exponential equation, I have y equals a times b to the x. All right, so the a is your starting number, which is still your y-intercept. So 3 is your a in this case. So y equals 3 times the rate or the multiplier, that is your b. We're multiplying by 2, so that is my b. So 3 times 2 to the x would be that equation. And in the last one, let's see, it has a y-intercept of 2. That's my starting amount, so that is a on an exponential function. This one keeps going down, and so my multiplier or my rate is actually 1/2. And so that is how you would write that equation. Where are we at? 19 minutes. Doing good. All right, so from a word problem, you want to look and you want to see, do you see a linear or an exponential function? Do you go up or down by adding or subtracting, or do you go up by multiplying? All right, so a library has 8,000 books. It is adding 500 more each year. So since I'm adding, that makes you a linear function. So I have 8,000 books, so that is your starting amount, which is your B. and you're adding that much, so that is your rate of change, so that makes you the m. So in a linear, I have y equals mx plus b. That gives me y equals 500x plus 8,000. The next one, I start with 50 in my account, and this time I'm going to use 425 every day. So my account balance is going to go down. When I use it, that's just subtraction, so this is also a linear function. I start off with 50 in my account, that is your initial amount, B, and that is going to be my M. So this is y equals negative 4.25x plus 50. You got to know that if you're going to use it, that is subtraction, and that is what makes for a negative slope. Let's see if I can get through the next two before the bell. My account starts with $10. Every month, that amount of money is tripled. So tripled is the same thing as multiplying by 3, so that is your rate, and that makes b equal to 3. I'm starting with $10, so that is your a, and this is an exponential function here. So in my equation, y equals a times b to the x, I get y equals 10 times 3 to the x. And in the last one, I have 20,000 owls. Every decade, that number is halved. So that is the rate. It is decreasing by half. And so b equals 1/2 in this problem. And I'm starting with 20,000 owls. So this is an exponential function, because it is going down by multiplying by a half. My starting amount is 20,000. So a is 20,000 times 1/2 to the x. All right, have a good one.